Hello, 4th Sem MTT students. Welcome. We are working on question bank. The first chapter is first CO is basic principles of measurements. We shall study this one. The first question is define metrology. What do you mean by metrology itself? It can be defined as science of measurement depending on the quantity being measured. It can be defined metrology of pressure, metrology of temperature, metrology of uh, pens, etc. Medical metrology, engineering metrology depends on field of application. Metrology may be industrial metrology, medical metrology, engineering metrology. Engineering metrology is restricted to a measurement of length, angles, and other quantities expressed in linear and angular terms itself. Therefore, metrology is the branch of science which deals with the measurement of the different quantities, right? Such as a pressure, temperature, any medical terms itself, right? But the engineering metrology depends upon the what you call as the length and angle measurements and other quantities expressed in terms of linear and angular terms itself. This is the first question. Now we shall have the second question, that is explain legal metrology. Legal metrology means what? It is directed by national organization called National Services of Legal Metrology NSLM. It includes number of international organizations whose object is to maintain uniformity of measurement throughout the world. Thus, legal metrology consults with units of measurement, methods of measurement, and measuring instrument itself. See, in whole world has to follow only one system. Whatever we are using here for the linear measurements is a meter, is a centimeter, is a millimeter, is kilometer, right? The same should be there in England, in America, in Japan, in Scotland, in other parts of the world itself. Suppose we are choosing the particular length as millimeter, the same particular length must be millimeter in the other countries also. For that purpose, we require a legal metrology, and this legal metrology is maintained by the NSLM, that is National Services of Legal Metrology. National Services of Legal Metrology. Right? This is what we are having the things itself. Right? Now we shall go for the next part, that is what are the functions of NSLM. What are the functions of NSLM? First one, to ensure conservation of national standard. Whatever the national standard has been there, we must be able to conserve it. It should not be changed. Right? That is the first function of a NSLM. Second one is to guarantee the accuracy by comparison with international standard. It must able to ensure the accuracy by comparing it itself. Third one, to guarantee the accuracy will be imparted from primary standard to secondary standard. When we are transferring the accuracy from the one standard to the another standard, there must be a guarantee, which guarantee will be given by the NSLM itself. Next, fourth one, to carry out scientific and technical work in the fields, to carry out बनता चला गेला हाँ चला ओके Fourth one, to carry out scientific and technical work in the fields of metrology and methods of measurement itself. The scientific and technical developments has to be taken out by this NSLM. Fifth one, to take part in the work of other national organizations interested in the metrology. Other national organizations which are interested in the metrology, in that part, that also this it has to take the part itself. Sixth, inspect use of instruments covered under the public guarantee. And seventh, to detect frauds of measurement. There will be many frauds of measurement that should be detected by the NSLM itself, and to organize training legal metrology. Legal metrology has to be training of the legal metrology has to be carried out by this NSLM. This is the question we are having, that is number 3. Fourth question is explain need of inspection. Why the inspection is needed? Inspection can be defined as act of comparing materials, product and components with some established standards. In old days, production was small scale. Same operator will assemble the parts made by him. So he will make necessary adjustments to make a perfect assembly functioning properly. Hence, there is no need of inspection. In the old days, what happens? There will not be any mass production. Only one operator will producing all the parts of an assembly, and he is making any adjustments, any corrections required for the assembly of the perfect assembly of the parts. Therefore, there is no need of any inspection. But nowadays, as the technology develops, new methods of manufacturing and large scale production begins. Thus, in mass production, component must be accurate. Components must be accurate to have a perfect assembly. Hence, there is need of an inspection. See, as I already told, the last in olden days, what happens? Only one worker is producing the whole assembly of the machine itself. Therefore, whatever the corrections required, whatever the adjustment required, he is making that one and making the assembly do or work perfectly. But nowadays, the parts are produced by one person and assembly will be done by the other person. Therefore, there is a necessity of inspection. Next, we are having a question number 5. Explain principles of measurement. Explain the principles of measurement. Measurement is essential part of technical development. Lord Kelvin says, when you can able to measure anything and express it in terms of number, it says that you know something about it. On the other hand, if you are not able to measure it and express it in terms of the number, you are not having any knowledge of measurement. During the measurements, the following terms are very important itself. Right? The Kelvin says, what the Kelvin says, if you are able to measure the parts and express its measurement in terms of number, then you know something about the part. If you are not able to measure and tell the result in terms of numbers, you are not knowing anything about the part itself. That one he has told, and some important terms are there which are very important for the measurement itself. First one is measurand. It is a physical quantity to be measured. It is a physical quantity to be measured is called as the measurand. Example, length, diameter, angle, etc. Second one is reference. It is a physical quantity used for measurement. Example is steel rule, vernier caliper, etc. Steel rule, vernier caliper, etc. Next, third one, comparator. It means comparing the measurand with reference. Example, eye contacts, etc. etc. Next, sixth question. Explain measuring system. What do you mean by measuring system? Measuring system is made of five basic elements. One is the standard, second is the workpiece, third is the instrument, fourth person, and fifth environment. With all these elements, the system will be formed, and that is known as the measuring system itself. Next is accuracy. Define accuracy. Accuracy can be defined as agreement of measured value with the true value of the measured quantity itself. If the measurement of dimension of a part is nearly equal to the true value, then it is said to be accurate. If the measured value is very nearly equal to true value, then you can call it as accurate. Next, precision. Define precision. It can be defined as repeatability of the measuring process. It refers to the group of measurements for the same characteristics itself. Group of measurement for the same characteristics is known as the measuring process, and it is called as the precision. Precision is repeatability of the measuring process itself. Now we shall have the next question, that is distinguish between precision and accuracy. Distinguish between precision and accuracy. You see there we are having a, what do you mean by precision, what do you mean by an accuracy itself. First one, precision is repeatability of the measuring process, whereas accuracy is agreement of the measured value with the true value. Precision is group of measurements for the same characteristics, whereas accuracy is individual measurement of a single characteristic. Then we are having a graph. See the graph itself. First we shall have the frequency versus dimension graph. Frequency versus dimension graph, right? We are having an average, and then we are having a true value. Here we are having a true value and average itself, right? This is what we are having the thing. Next, what are the basic components of accuracy evaluation? What are the basic components of accuracy evaluation? First one is factors affecting the calibration standard. That is the standard. Therefore, it is called as the S, calibration standard. Second, factors affecting the workpiece. Therefore, it is called as the W, workpiece. Then third one, factors affecting the characteristics of instruments. Characteristics of instruments. Instruments, I. Then fourth one, factors affecting the person. Factors affecting the person, P. Person, P. And then factors affecting the environment. Factors affecting the environment. Thus we are having first, we are having a standard, yes. We are having a workpiece, W. We are having an instrument, I. We are having a person, P, and environment, E. Thus we shall have a swipe, SWIPE, swipe. If you remember the swipe, you can easily remember the factors affecting the accuracy itself. S means standard, W means workpiece, I is the instrument, P is the person, E is the environment itself, right? These are the what we are having, how to remember the things itself, right? Then we shall have factors affecting the calibration standard. What are the factors affecting the calibration standards, right? First one is coefficient of thermal expansion. If the coefficient of thermal expansion is small, with a small heat, that is in the room temperature itself, the part will be expanded, right? Therefore there is a what error itself. Second one is calibration interval. In how many days? Frequency. In how many days we are making the calibration itself. C, stability with time. With the time move goes, how much it is stable, whether it will lose its stress strain itself, that is to be studied itself. Next we are having elastic properties. What are the elastic properties of a part itself? Whether it will retain its properties or it convert into the plastic itself, that one we have to see here. Then we are having a geometric properties. Shape of the part has to be maintained, it should not be changed. Suppose it is a circle, it should be circle, it should not be converted into the oval shape or an elliptical shape itself. Thus we are having a, these are the five the factors affecting the calibration standard itself. right? Next is define a sensitivity. What is the sensitivity we shall have? It is defined as rate of displacement of indicating device of an instrument with respect to the measured value. It is the rate of displacement of indicating device of an instrument with respect to the measured value. It can also be defined as ratio of scale spacing to the scale division value. Scale spacing divided by scale division value is also called as the sensitivity itself. Example, in dial indicator, scale spacing is 1 mm and scale division is 0.01 mm. Then the sensitivity is equal to scale spacing divided by scale division value, which is 1 divided by 0.01, which will be 100 itself. Therefore sensitivity of a dial indicator is 100. Next question is defines readability. What do you mean by readability? It is an susceptibility of the measuring device to have its indication converted into a meaningful number. Susceptibility is very important term. It is a technical term. You have to remember this one, and this word should come in your answer in the examination itself. That is very important. Therefore, you remember this word, that is the susceptibility. It is defined as susceptibility of the measurement to have its indication converted into the meaningful number itself. That is the ability of an instrument, measuring instrument, to have its indications converted into the number itself. Therefore susceptibility word is a technical word. It should come, then and then only you will get the numbers, that is the marks itself, right? Next question is define calibration. It is the process of framing the scale of instrument by applying some standard signals of measuring instrument. It is the free measuring process carried out by manufacturer. It is free measuring process carried out by the manufacturer itself. Next question is define magnification. It can be defined as improving the magnitude of the output signals of the measuring instrument by many times to make it more reliable. The magnification means it is defined as the improving the magnitude of the output signals. The output signals should be improved. Output signals must be magnified of the measuring instrument by many times to make it more reliable, more readable itself. 15. Define repeatability. It is an ability of the measuring instrument to repeat the same result to the measurement of the same quantity under the following conditions: same observer, same instrument, same condition, same location, same method of measurement, and short interval of time itself. That is known as the repeatability. It is an ability of the measuring instrument to give the same results under the conditions of same observer, same instrument, same condition, same location, same method of measurement, and short interval of time itself. Next is define producibility. It is the consistency of a pattern of variations in the measurement when carried out. It is the consistency of the pattern of variations in the measurement when carried out by the different observer, by a different method, by a different instrument, by a different condition, by a different location, by a different time itself. By these things we shall have the producibility. Next is define error. Error can be defined as the difference between actual value and the measured value. Therefore, error is equal to actual value minus measured value itself. There are two types of errors. One is absolute error, second one is relative error. Absolute error is the algebraic difference between the result of measurement and true value of the quantity, whereas relative error is the quotient of absolute error and the measured value. Therefore relative error is equal to actual value minus measured value divided by the measured value, right? This is what we are having a relative error. Thus we are having a two types, important types of errors: absolute error and relative error. You have to remember itself. Next is what are the types of errors itself? The types of errors is first one is static error. Here we are having a reading error itself. right? There in the figure we are having an length is to be measured is 40 mm. Measured length is to be 40 mm. If your eye is just exactly perpendicular to the 40 mm, you will get the correct result, accurate result itself. If your eye is towards the left, you are getting higher value. If the eye is towards the right, we are getting lower value, that is 43 and 36 in the figure itself, right? This is thing we are to remember, right? The static error results from physical nature of component of the measuring system. There are three sources of static errors. One is reading error, one is reading error. It depends upon the position of the reader as shown in the figure, that is will give us a parallax error itself. Next is characteristic error. It is defined as deviation of the output of the measuring system from the theoretical predicted performance. From the theoretical predicted performance, it is a deviation of output of the measuring system from the theoretical predicted performance itself. For example, hysteresis, for example repeatability, for example resolution of errors itself, right? Next we shall have the third one, that is C, loading error. It results from inaccurate loading of the component to be measured. Inaccurate loading of the component will result as loading error. Environmental error, the results from the effect of surrounding such as temperature, pressure, humidity on the measuring system will give us environmental errors itself. Then we are having a dynamic error. Till we have studied static errors, which will give us a reading error, characteristic error, loading error, and environmental error. Now we shall have a dynamic error. It is an error caused by the time variation. The instrument it occurs in the instrument occurs it occurs in the instrument containing moving parts due to the friction, lapping, and inertia. The it may be a systematic error. These are regularly repeated in nature. These are regularly repeated in nature, and they are constant and similar form. They are constant and similar form. There may be controllable and are calibration error. These are caused due to the variation in the calibrated scale from the normal value, small normal value itself. Ambient error, the atmospheric conditions will leads us to the ambient error itself. That is change in the temperature, pressure and moisture in the atmosphere will cause the variations, and that variations are called as the ambient errors. And to get a perfect value in the measurement, we have to keep a temperature of 20 degrees centigrade, a pressure of 760 mm of Hg, and a stylus 760 mm of Hg in during the measurement itself, and a normal moisture is to be maintained, right? Next we shall have stylus pressure. Another common source of error is which is on the workpiece is pressured during the measurement itself, that is the stylus error. Avoidable error, these errors occurs due to the parallax, improper alignment, and improper correlation itself, right? They can be easily avoided. Random errors, these are consistent, they occur randomly and they are identical in nature and they cannot be avoided and controllable itself. They occur in not expecting, we are not expecting here, and they will be coming itself, right? Here is we are having a difference between systematic error and random error. You can see the difference is there, right? I have listed five differences itself, and you can read and remember the things itself. These are repetitive nature, that is systematic error are repetitive in nature, whereas they are non-consistent in nature, that is random error are consistent in nature. These errors result from improper conditions. These error results from improper conditions. They are results from natural in measuring system or instrument itself, right? Except personal errors, all such errors can be tolerated. controlled in magnitude and sense itself, whereas random errors cannot be easily controlled and there is no question of itself and they are come without our knowledge of measuring system and conditions. So thus we are having a five different types of the different methods I have given. Just note them and get the things cleared itself. Right. Next we shall go for the standards. Define standard and list the types of standards. Standard is defined as something which is set up and established by authority as a rule for measure of quantity, weight, extent and quality are the examples. Example is a meter, standard to measure the length, gram, standard to measure the weight, liter, standard to measure the liquids. Right? Thus we are having and standard is defined as a something which is set up or established by authority as a rule of for the measure of quantity, weight, extent and quality itself. There are three types of standards. One is the line standard, second is the wavelength standard, and next is the end standard itself. Right? The line standards are two. One is the yard, and second is the meter. First one is add as shown in the figure itself. Yard is also called as the imperial yard, and it is existed in the different countries in between 1853 to 1960. 1853 to 1960 yard is established in 1853 and it is continues to be the measuring instrument for the length measurement in up to 1960. Imperial yard is made of 1 inch square bronze bar with 82% copper, 13% tin and 5% zinc. It is 38-inch long bar and has two half-inch deep holes set at 36 inch apart. Holes are filled by the 1 by 10 inch diameter gold plugs as shown there, laying on the neutral axis because the bending of the beam does not affect the neutral axis. Plugs are protected from the accidental damages. Top face of the gold plugs are highly polished and contains three transverse lines and two longitudinal lines. Yard is defined as a distance between the two central transverse lines on the plugs at 62 degree Fahrenheit. It is legalized in 1853 to 1960. Next is meter. The figure shows the meter itself, right? And this meter, this is the meter. This standard was established originally by an International Bureau of Weight and Measures in 1875. Meter is made of platinum iridium alloy with 90% platinum and 10% iridium, having a cross section of 16 mm into 16 mm as shown in the figure. The upper surface of the web is highly finished and has two fine lines engraved over it. This bar is kept at 0 degree centigrade at normal atmospheric pressure. It is supported over the two rollers at a distance of 589 mm. So to have a minimum deflection, the distance between two lines is taken as 1 meter. This is kept by the BIPM in France. It is Bureau of International Pounds and Measures kept in the France itself. This is what we are having and meter itself, right? This is the meter we are having. See the figure. You will get the things itself. The total length is 1000 mm. Distance between the rollers is 589 mm. The two rollers are kept at a different what that is the supports itself, so that it cannot be bent. Right? Suppose it bend also, the neutral axis will be remain same. This is what we are having and meter. Right? Next question is. Uh, Explain briefly wavelength standard. Wavelength standard. Briefly, wavelength standard. The drawback of metallic standard square or meter square are changing with time. It is finding difficulty in comparing and maintaining the standard. Hence, French philosopher subjected a wavelength of a monochromatic light can be used as standard of measurements. The orange radiation of isotope krypton 86 Kr86 was chosen for new definition of length in 1960. Thus, meter can be defined as wavelength of orange radiation of krypton 86 gas at 63 degree centigrade produced in the hot cathode discharge lamp. Thus, 1 meter is equal to 1050763.73 wavelength. It is not a physical standard, hence it is not necessary to preserve. 1 yard is equal to 1509458.3 wavelength is also equal to 0.7971 meter. Right? This is what we are having the wavelength standard itself. Right? Next is end standard. When the length is expressed as distance between the two flat parallel plates is known as end standard. Example, ends of a micrometer, anvils of a vernier caliper and slip gauges are called as the end standards. It is expressed in between the two flat parallel faces of the different parts itself. This is known as the end standard. Next question is, what are the characteristics of end standard? These standards are highly accurate, used in precision engineering. Measure only one dimension at a time, require more time for measurements. Flat faces may be weird. These are not subjected to parallax error. These are the six different characteristics of a end standard. One is highly accurate, used in precision engineering. It can measure only one dimension at a time, and the more than require more time for the measurements itself. Flat faces may be weird, and these are not subjected to parallax. Then last question is, explain subdivisions of standard. The subdivisions of standard itself. The imperial standard yard, international standard meter are perfect or master standards, and they are not used directly for the general purpose itself. And these standards are subdivided into four grades. These standards are subdivided into four grades. One is primary standard. It is the only 1 meter or only 1 yard which is preserved under most careful condition. It is used only at a time when only at the rare intervals, say after 10 to 20 years, for comparison with the secondary standards, and it has no direct applications in the engineering problems. Thus, primary standard is the only one standard for the whole world, and it has been kept in the Geneva, right, under highly tight security, right, and it is not used directly for the measurement, right, it is only for checking or comparing the next standards known as the secondary standards, right, and thus we are having a primary standard is the only one standard. Next we shall have secondary standard. See, the primary standards are only one, therefore its replicas of nearly 10 to 20 pieces are produced, and they are kept in the different capitals of the different countries, right, for the under safe security itself. And these are made up of nearly as possible exactly similar to the primary standards, and in design and in material and in length they are compared with the primary standard often after a long time intervals itself, and records of deviations are noted. These are kept in number of places for safe custody, and these are used for the occasion of comparison with the one more type of a standard known as the tertiary standards. tertiary standards, and these tertiary standards are replicas of the what that is a secondary standards, and for every state we shall have the tertiary standard, and it is also kept in the capital of the every state, and it is also not used for the measurement itself. It is only went for comparison, which is the working standards used by the whole world itself, right? That is the things. These are the first standards to be used for the reference purpose in the laboratory, and these are made as true. These are made as true copy of secondary standards, and they are used for comparison with the working standard itself. And lastly, we shall have a working standard. These are available with the every mechanic who is making the supervision in the measurement itself, right? And these are used in the workshops for measurements, and these are made of same primary, secondary, tertiary standards, both in line and length and working standards are used itself. This is what we are having, the total chapter basic measurements itself, right? And the students, please see this online YouTube uh, content, and keep asking, keep listening these things, so that whatever the words come from my mouth will go into your head and remain there, and when it is required, that is during the examination, will come will transfer into your hands, and with the help of a pen they will be reproduced on the paper itself, right, which will fetch you a large number of marks. Thank you one and all, and I wish you and both best success in the coming examinations, which will be scheduled after 1st July. Thank you one and all. Thank you one and all. Thank you one and all. Thank you.